Motor thermal overloads are sized based on nameplate amperage if provided. If not, the full load current or FLC tables are used. Based on that figure, the heaters can be correctly sized per 430.32 of the National Electrical Code or NEC. Based on the FLC values, 125% of that value is added to get the ampacity needed for the branch circuit wiring. Depending on the overcurrent protection choice, the FLC value is multiplied by either 175% or 250% to obtain the overcurrent protection for short circuit and ground fault protection, as per NEC table 430.52. Let's consider this example a branch circuit feeding a single-phase, 2 horsepower, 115 volts motor. The full load current, or FLC, is 24 amps. The heater size is 24 amps multiplied by 115%, which equals 27.6 amps, minimum. And 24 amps multiplied by 130% is 31.2 amps, maximum. The overcurrent protection device, or OCT, is 24 amps multiplied by 250%, which equals 60 amps using an inverse time breaker, which happens to be a standard size. From the overcurrent protection device, or OCT, it's permissible to run size 10 American wire gauge, or OC, THHN wire, which is good for 30 amps. But what happens if the heater short out or become faulty? In that event, the motor can interlock rotor current, and the next device set to trip would be the breaker set at 60 amps. How is it that you can have size 10 AWG wire leaving a 60 amp breaker? The only way that motor will draw more than 24 amps is if it goes into a locked rotor condition, at which point the current will greatly exceed 60 amps, tripping the breaker and protecting the conductors. When a motor experiences a locked rotor condition, it draws a significantly higher current than its normal operating current. This current will exceed the ampacity of the size 10 AWG THHN wire, which is rated for 30 amps. However, the 60 amp breaker is designed to trip before the wire can overheat and potentially cause a fire. The key to understanding this lies in the breaker's design and function. It's engineered to trip at a specific current threshold. This threshold is set higher than the motor's normal operating current but lower than the locked rotor current. Consequently, the breaker will only trip if the current surpasses the locked rotor current, which represents the maximum current the motor can draw. Continuing with the example, the motor's nameplate current is 24 amps. Its locked rotor current is likely to be around 6 times that value, or 144 amps. The 60 amp breaker is calibrated to trip at a current between the normal operating current and the locked rotor current. Therefore, the breaker will trip before the wire can overheat, even if the motor enters a locked rotor condition. It's crucial to remember that this is just an illustrative example. The actual trip current of the breaker will vary based on the specific breaker model and the motor's characteristics. However, the underlying principle remains the same. The breaker will trip before the wire can overheat, even during a locked rotor event. The 60 amp breaker doesn't provide short circuit protection for size 10 American wire gauge, or OC, conductors. The motor overload heaters are for that specific purpose. If the motor overheats or tries to pull too much current, then the heaters will open, and the motor will stop. A short circuit in the motor or its supply wires is an entirely different situation. Motors can withstand locked rotor amperage, or LRA, for a short period, giving the overcurrent protection time to work. This is based on the thermal withstand capability of the motor. Firstly, consider the motor overload protection, which are the heaters. These devices are designed to protect the motor from overloads, not short circuits or ground faults. They are sized according to the motor's nameplate current and are intended to trip if the motor draws excessive current for an extended period. Secondly, the branch circuit overcurrent protection, which is the breaker, protects the branch circuit conductors from short circuits and ground faults. It's sized to allow the motor to start and run without tripping, but to trip quickly in the event of a fault. Thirdly, the size 10 American wire gauge, or OG, while leaving the 60 amp breaker is protected by the breaker in the event of a short circuit or ground fault. The breaker will trip quickly enough to prevent the wire from overheating and causing a fire. The motor draws more than 24 amps only if it goes into a locked rotor condition. At that time, the current will greatly exceed 60 amps, tripping the breaker and protecting the conductors. The branch circuit breaker protects the conductors from overcurrents due to short circuits or ground faults, while the motor overload relays protect the motor from overloads. The motor overload relays are sized to protect the motor from damage due to sustained overcurrents, which could be caused by a mechanical overload or a voltage drop. The branch circuit breaker is sized to protect the conductors from short circuits and ground faults, which could cause the conductors to overheat and potentially start a fire.